Hello and welcome to Amazon Web Services webinar, Strategies to Quantify TCO and Optimize Cost using AWS. Before we begin, let me walk the audience through a few housekeeping items. On your screen, you can see a Q&A pod. Please submit your questions for our presenters and moderators at any time, and we will address them throughout today's presentation as well as in the live Q&A session in the end. In the end of the presentation, there will be 3 poll questions preceding live Q&A. Today's webinar is being recorded. We will send you a follow-up email with the URL to the recording once we verify the recording quality, as well as a link to the presentation deck. And again, welcome to today's webinar, Strategies Quantify TCO and Optimize Cost using AWS. Our presenters today are Amilcar Alfaro and Gary Makula. Amilcar has over 15 years of experiences in product management, product marketing, and business economics. Currently, he is the product marketing manager in AWS. Prior to this, he has worked for several Fortune 500 companies in the software, services, and medical device business. His core areas of expertise are business economics, pricing, licensing, and core product marketing. Gary is the Senior Director of Information Security for FINRA, an organization dedicated to investor protection. Prior to this, he has held a variety of development and engineering positions in areas of system and application development, database architecture, and networking engineering. At FINRA, he has built and is responsible for many expertise-wild security solutions. He and his team built many custom security controls and has taken advantage of the power of Splunk. He is passionate about data-driven metrics-based decision-making and leveraging big data to the end. Today with us, we also have several Q&A moderators. We have Adam Glick and Michael Beckman from AWS, and Tony Bolender and Praveen Ragnath from Splunk. They will engage with you and answer questions throughout today's presentation while our presenter present. Amilcar and Gary, welcome, and now pass the floor to you.
Hello, everybody. Good morning, good evening. Welcome to the webinar. We're very happy to have all of you here today. As it was mentioned a minute ago, we're going to be talking about the strategies to quantify TCO and optimize costs using AWS. We're also very fortunate to have a great customer with us. FINRA is going to be talking through some of their individual scenarios and how they've worked through some of their cost optimization strategies. So we hope you find this information valuable, and let's get started with the content. So one of the main things that we always want to start a conversation with is to remind everyone how AWS empowers organizations how to rethink and manage their business infrastructure. With AWS, you can do a lot of different things, and in terms of your infrastructure, the main 3 tenets that we try to consider are how you can scale based on market needs, how you can increase innovation and experimentation, and how you can leverage what you already own. So what we're going to be focusing on today is we're going to be talking about how to frame a value discussion using AWS, how AWS can lower costs, and how you can optimize costs to drive business value. The first point when we think about how to frame a conversation about value when moving to AWS is that every conversation should start with your goals. The macro objective here is that your goals should be the driving definitive factor that helps you think about how you're going to be using and leveraging AWS solutions and technologies. So for example, we need to focus on moving our core business forward, not moving and building infrastructure. That is one of the main and fundamental reasons why people choose to move to AWS. Another option is to reduce our overall cost, which is a very high priority. These are all customer quotes, by the way. And also, we look how to improve performance and expand globally in a flexible way. All these 3 are very common business goals that are the driving and motivating factors for people to move into AWS. So this is not just something that we talk about without having any validation. We've gotten really great support and validated information from analysts. So the report that you're seeing here, the snapshot you're seeing here, is information that comes from an IDC report that highlights some of the great financial findings from customers using AWS. So at the highest level, we have identified how customers can increase return on investment by over 500% when moving into AWS. Similarly, they have the ability to drive growth in applications by $1.5 million over a 5-year horizon. And they can also achieve great returns in their payback lower than 6 months. So in 5.5 months, many customers have seen their full investment in AWS be paid back in full. Additionally, we can see how there are some average benefits on an application basis, such as risk reduction and business productivity improvements of around $182,000, IT productivity gains of $133,000, and cost reductions of $131,000. So these are important costs that really help understand how AWS can have real financial impact on your organization. So today we're going to dive deep into costs, and we're going to talk a little bit more about what it means to identify how costs are both identified, quantified, and evaluated when thinking about AWS. So the first thing to consider is that AWS and traditional on-premises or colocation infrastructure, TCOs, are not necessarily easy or identical. They have to be compared using a more comprehensive approach. So comparing TCO is not necessarily something straightforward. And what we're going to do today is go through the entire principles of what it means to identify these costs. So the first tenet is that AWS helps you reduce costs compared to on-premises environments. So let's talk a little bit about what that means. The first situation to consider when you're looking at an on-premises traditional data center is that you have a very significant investment in capital expenditures. You've probably acquired a significant number of servers. You might be leasing or have acquired property. You might have some infrastructure to support cooling and powering. So there are investments that you've already made that are, for lack of a better term, in the books. You've already made some capital investments. Additionally, you have all your operating budget where you need to support through having IT support. You need labor, you need security, you might need some software licenses that need to be either paid on a subscription basis. So there's a significant investment both from capital expense and operational expense. When you look at a more intensively virtualized data center, what you start to see is that you can reduce some of these costs. For instance, you can reduce capital expenditures because you're going to need less hardware. You're going to need less servers to run a similar virtual machine density. Similarly, you might be able to reduce operational expenses because you need less people to manage the same infrastructure, or you might need less dedicated resources for a single workload. You might have the ability to redeploy people more strategically. But when you move into AWS, one of the main differences and one of the real value drivers is that suddenly this capital expenditure gets diminished. I mean, it really pretty much is non-existent because you're no longer required to manage this physical plant and all the infrastructure that you used to spend tons of money and time in the past. So AWS allows you to focus on truly driving scale without having to manage this big this capital infrastructure. We drive hyperscale with multiple new data centers built each year. We have hugely developed and automated processes and supply chain optimization that allow us to get some economies of scale that are very difficult to replicate when you try to compare against a traditional on-premises managed data center. And that allows us fundamentally to drive greater utilization that is higher than what you would see in an average benchmark solution. Similarly, Amazon has developed some very specific hardware designs. We have very significant relationships with OEMs and vendors of networking gear that allow us to truly get optimized solutions that are, again, designed to scale and designed to be controlled in a highly automated level. So when we think about what the cost drivers are when you evaluate a full data center, we typically break down cost categories into 4 different solutions or 4 different areas. So the first area are the server costs, the storage costs, networking, and IT labor. However, these costs are not just monoliths. They're not just one single expense. There are multiple components that are built into all these categories, and that's where the details come in, and that's where the costs need to be truly evaluated. So when we look at the server costs, it's not just the hardware. It's the racks, the PDUs, the switches, all the maintenance. It's really much more just than the cost of acquisition of the box itself. Additionally, you have all the licensing for the software, the operating system. You might need virtualization licenses, whatever applications are sitting on top of that. So there's definitely significant costs in addition to that. Similarly with storage, when you think about what accounts the full storage costs, it's not just the costs of the hardware and the disks, You also need to think about the storage administration costs if you're doing backup, if you're doing archiving, purging. There's a lot of different things that go into the cost of storage. Networking, same principle. It's not only the hardware. We have the LANs, the switches, load balancers, but we also have the network administration costs. And there's a significant expense going on there. And when we think about IT labor costs, of course, this is something that everybody has to go through. And there's the money dedicated to support, administrate, manage virtualization, keep everything up and running. And those are the fundamental categories. However, there is one area that typically gets overlooked, and that is the overhead. All these different solutions require space, they require power, they require cooling, and those are not immaterial costs. A lot of these different costs really add up very quickly. They take money that could be easily dedicated elsewhere, in addition to the fact that they're complex to manage. So when you think about moving into AWS, a lot of these different costs are accounted for when you think about how you're getting the value of your services. So let's think a little bit about what it means to plan for traditional data center capacity planning. So there are some significant limitations when you think about how a traditional data center gets planned and built. The first thing is that traditionally it's done through a forecast model that requires, for lack of a better term, a bet into the number of assets that you're going to need. So suddenly you're faced with inflexible physical assets, whether you bought for overcapacity in peak or whether you bought for your average utilization. You might be in a situation where you're suddenly stuck with a certain number of physical assets that might not be easy to grow or shrink, and therefore you have underused assets. Second, costs are typically never in sync. Business, unfortunately, for the most part, is not necessarily a traditional growth curve or a smooth curve. There might be spikes, there might be peaks and valleys, and some of these different variants in the run of the business, on the run rate of the business, require that costs have to be managed according to the requirements. So it's difficult to budget and it's difficult to forecast when you have unpredictable variance. Similarly, when you think about growing or perhaps expanding or consolidating, suddenly you also look into what it costs to migrate and expand. So as you do your forecasting and as you do your yearly budgeting, typically costs of migration, expansion, and all sorts of modifications on the fly are not easy to take into consideration. So capacity planning at that level is also hindered by some of the inefficiencies of the guesses that you have to make up front. Lastly, there are a number of unexpected costs and inefficiencies. Perhaps there's a huge spike in demand that you didn't oversee. Perhaps there's an acquisition that now requires you to integrate two different systems. So all of these different things raise costs to a point where it might be rather complicated to continue growth in the traditional capacity planning. So one of the things that we like to think about when we look at AWS, and I'm going to build this chart, apologies up front for the sluggish experience, is how you think about the infrastructure costs for AWS. So when you think about traditional hardware and traditional demand, demand is usually modeled as a straight line. We all want to assume that our growth or our needs are going to grow essentially on a linear basis. So to meet that expectation, we need to think about purchasing and acquiring assets in a step function so you can actually meet that demand and then grow accordingly. However, actual demand is much more of a wavy curve. It's something that actually builds with time, and it can actually grow and it can actually shrink. So what you end up with is having some peaks and valleys, some underutilization, and some missed opportunity costs. So when you think about using AWS, what you end up having is the ability to meet through a on-demand pay-as-you-go model, the ability to meet those peaks and valleys and actually build for the overcapacity and the reduction in capacity as you see fit. So there's a very fundamental way in how you think about changing the way you plan and how you look at infrastructure management. So let's switch very quickly and show you how you can actually estimate some of these costs using an online TCO calculator that we have developed, and that's available online. It's available through our Economic Center, and that you can use to get your own estimations. So the TCO calculator that we're showing right now is a simple tool that allows, with the use of a very small number of fields, the ability for you to calculate what it would cost to get some basic infrastructure and compare the TCO costs with on-premises or co-location environments. So for example, if you were going to test a virtual machine that had 6 VMs, these are random numbers, 8 cores, 32 gigs, you would be able to very, very quickly do an estimation that shows you how these costs are accounted for and the savings that you could achieve by using AWS. So this report will give you not only a 3-year cost breakdown, it will give you all the different numbers that are relevant to all the individual categories, and you can subsequently get all the details of how the calculations get managed, the recommendations of the solutions that are best fit to optimize your costs, and how you can get the breakdown for all the different categories. So this calculator, as mentioned a few minutes ago, and the link will be provided at the end, is available on our Economics Center. It's something that you can use both in advanced and basic mode. You can download the report, change a number of assumptions, even price on your local currency. So let's switch back to the presentation and move into the next section. So another important thing to think about with AWS is that even after initial deployment, AWS continues to drive down costs. So the opportunity cost increases over time. It's not just the cost of migration that is beneficial, but rather the incremental benefits that you really accrue as the solution continues to be running on the cloud. So for example, with AWS, many upgrades occur automatically because with on-premises infrastructure, you're responsible for all the upgrades, all the management, all the maintenance. That is a very costly thing that usually takes a long time to plan. It requires or might require business stoppage, or it might require delays to not have business stoppage. For example, you would not want to delay during the retail season and Christmas any shopping experiences because you need to manage infrastructure, so that might delay everything until the new year. However, with AWS, all the upgrades that are our responsibility happen automatically. You're always consistently up to date in the basics and the fundamentals of the technology you acquired. Similarly, because we're a managed services organization, we eliminate many of the operational tasks. So a very simple example, for a do-it-yourself MySQL replication, you could go through as many as 100 manual steps to achieve the results you need. Whereas when you think about doing the same thing with Amazon RDS with multi-availability zones, you can do that through one click. So it's really a very significant departure from the level of complexity that you might have done when you were building things on your own. Another way that we can help you reduce costs is with a new concept called EC2 dedicated hosts. So you might have heard some of that, and we're going to make a very brief mention of what this means. EC2 dedicated hosts are essentially physical servers with EC2 instance capacity dedicated for your use. So if you have very specific compliance requirements, if you have licenses that you want to port into our solutions, if you have a significant investment in underlying agreements with other vendors that you want to have on dedicated hardware, with EC2 dedicated hosts you can easily do that. So that allows you to bring your own license and really get very clear visibility, very clear asset management in how you're managing your infrastructure, how you're assigning licenses to different devices, how you're using your products, and it gives you very granular placement controls that enable you to reuse the same physical host over and over again. And what we've learned is that one customer saved as much as 42% in their investment only by using their own licenses. So if you think about the savings by coupling your own licenses, reducing the complexity of the managed services, and in addition to not having to manage the physical infrastructure, you really are on track to developing a very cost-optimized solution. So with that, let's move on into FINRA's section, and they're going to talk to you about how they've done a great job at optimizing costs and manage some of these solutions themselves.
Thank you, Amilcar. Let me move forward. Okay, so my name is Gary Makula, and I am Senior Director of Information Security at FINRA. And you may be wondering why a security person is here to talk to you about cost management. Well, I also am in charge of the Splunk implementation at FINRA, and we leverage Splunk to help us solve some pretty unique cost-saving methods, and I'm going to share a few of those with you today. So first of all, who are we? We're FINRA. We're the Financial Industry Regulatory Authority. We're in charge of regulating the 650,000 broker-dealers who trade stock every day. And not only do we monitor them, but we have to monitor all of the trades that are made that vary in volume. So I say on average 6 billion trades we have to monitor, but since that volume can change drastically day by day, that gave us the impetus to want to move to the cloud because we needed to be able to quickly adjust to our storage and compute needs to be able to handle with those changing volumes. And so that made the cloud become very attractive to FINRA. So when we're looking at cost management, there's a few things, paradigms that change when you move up into the cloud. The first thing is when you're on an on-prem situation, you may be very happy with, say, quarterly reviews or monthly reviews of your financials. But in the cloud, that's not really practical. The difference is that you're going to have developers clicking resources all the time, so the spends happen continually, and you're going to need to have a method that mirrors that continuous costing. The second thing is that you want to be able to get that real-time data down to, in a distributive model, down to the project managers so that they can ask questions like, how much am I spending? Am I over or under budget? Who is spending those dollars? So that they can make adjustments before quarterly reports come up and you have a very embarrassing discussion with your manager. The other thing is that if you look at just the billing reports, there's a lot of information in there, but they're really huge. So our detailed billing records was somewhere around 10 million lines. And I need to be able to get that information and correlate it with other information. So it's a real daunting task to have to deal with that much data. So what was our choice? Well, the first thing we chose is that we realized is that it had to be done distributively. We needed to push it down rather than have a centralized group handle cost management, that each project manager need to be responsible for that on their own. The other thing is we realized that saving money into the cloud is more of a discipline than it is a right. So just like there are different ways for investing for your future, one way might be to educate yourself and to carefully save money for your retirement, and the other way may be to buy lotto tickets. So both of them may work in different situations, but you need to be able to treat it like a discipline, and if you do, you'll be able to realize those benefits. So we decided to leverage Splunk for this because of its ability to easily collect, analyze, and visualize large sums of data. And one of the other key decisions we made was to handle the processing of loading the detailed records into Splunk. And that gave us some advantages that I'll talk about later. The other thing we found is that you're gonna want to enrich your data, something that Splunk is good at. So we want to get project codes, so we make sure that those are valid. We want to get forecast projections, so I need to know what your budget is if I'm going to tell you whether you're under or over budget. And the last piece here, billing adjustments, is really important because there's a lot of services in AWS where you can buy reserved services, and they come into the billing records as either 1 or 3 year commitments, but as single lines into there. And you're going to want to be able to amortize that data and be able to apply it to the right project codes, something that doesn't show up in those billing records. But we're able to do that through adjustments. And we've worked with several, or talked with several outside firms who sell solutions to be able to handle, or able to handle that scenario. And then we had to build the interfaces. So, okay, so let's talk about how we did it. This is an overview or schematic of the processes that we built. Up in the upper portion you'll see is the Python Bodo code that we use to pull the detailed billing report down, and we do some internal processing for that data, and we upload that into Splunk. And then on-prem we have a lot of our financial records. Some of them are stored in databases, some of them are stored as flat files, and Splunk has the ability to capture all of that data, and we put those as data inputs. And now with all this data together, we can build an application that can now present that to the users in a cohesive manner. Okay, I apologize for that. So anyway, now we can see in the upper left-hand corner, we have the daily spend. The blue line is the budget. I can see for each day whether I'm above or below budget. We update this data every single day so a project manager can come in and look exactly what his or her spend is. And below that we have cumulative totals so that I can see where I'm heading for the month. And if I click on any of the individual services, I can look at their accumulation individually. And so this little app, this helped us solve a lot of problems, and it helped us get immediate return on investment. So one of the things it did was it allowed us to deal with low-hanging fruit. We were able to shut down services on weekends and evenings in the development environment. That saved a huge amount. We're able to enforce better sunsetting of dormant EC2s and their associated storage, and that also saved money. And then we're able to take those best practices and put them over, to run them across all the environments. And we had a really big quantifiable cost savings, and within 1 month of when we rolled this out, we were able to actually reduce our billing record numbers by 17%, and that's huge. And that provided better tracking and better forecasting. And you might say, oh, actually, if I go back to this slide, we actually rolled this prototype out on this project within the first 10 days of it. And as you can see, that project was never below budget. And immediately when we got this information to the project managers, they were able to make adjustments by turning off resources and those types of things. And you could see there was a big change in the spend just by getting that information over to the project manager. Now you may ask, well, how long did this take to build? Well, this specific application was strictly a skunkworks project that myself and a staff member worked on, and we put this up within a week, just working on our free time. And you may also wonder, how much did it cost to build this? The amount of data that we put into Splunk to provide this data would cost you about $1,000 a year to be able to do that. And that is extremely a small amount of money to pay to be able to get that type of data. But now that you've handled things at a project manager's perspective, now that's not the only place you can get cost savings. You can also drill down into different services to figure out how you can squeeze more dollars out of there. And we use Splunk to help us do that as well. And I'll go over an example with you. And it's going to have to do with EMR. And if you're not familiar with EMR, it stands for Elastic Map Reduce, and it's basically Hadoop as a service in AWS, and it makes it really easy to start your own Hadoop cluster. Now, for those of you that aren't familiar with the cluster, it's pretty much just one or more master servers whose job it is to handle the control, and usually lots and lots of data servers, and those data servers handle the incremental work in order to satisfy requests. And we're going to talk about that a little bit. So what stood in our way? What stood in our way was that Hadoop as a service, or EMR, is a PaaS, or platform as a service, and not infrastructure as a service. So how are we going to get transparency into there? And one of the other things that was a problem was when you get your billing record, there's EC2 costs associated with EMR. There's also EMR costs and transfer costs, but none of it is brought together to say, how much did I spend to run this particular cluster? So how are we going to be able to identify the nodes and which of those EC2 servers were associated with my cluster or not? And how can I tell which ones were masters and which ones were data boxes? And then how can I get the tags that tell me which project they're associated with? And not to quickly go over this, we solved this by bootstrapping the Splunk agent and leveraging the metadata service that AWS provides, so that whenever we install the agent, we have a job that runs, calls the metadata service, and that can provide all this information, and then we tag that onto our records inside of Splunk. The other thing one of the other issues that we wanted to try to solve was the fact that through EMR, what happens is that your log records are pushed out to S3 every 15 minutes. And that was really a problem for our developers, because when you're in development mode and you send in a request, you don't want to wait 15 minutes to be able to see your logs. And by bootstrapping the Splunk agent, they can now get those real time. So that was an ancillary benefit that really helped us. And this is what the analyzer screen looks like, and this is how we correlate all the relevant data. So now that we can get all the cluster data together, we can now provide a billing section that lists every cost that was associated with that cluster. So when we start an EMR cluster and it comes down, I can tell you exactly to the penny what it costs to run it. Now we also integrate performance logs. So you can see CPU there, you can see memory, and that information is important when you want to try to do cost savings. And finally, we list the jobs that ran on that cluster, so that if we're doing comparison between two AMRs, we can make sure it's apples to apples. So where are the potential cost savings for EMR? The first thing has to do with which data hosts or types that you decide to use. You can pick any that you want, but you want to be able to tune it towards your performance so that you're not over allocating resources and spending too much money. And if I look at this specific example, I can see from the bottom graph that I'm a little CPU bound early in the process, and then it tails off. But memory, not so much. It never goes above 40%. But what we ran up on the top is the M1 X large box. And if we could run that now with a C3 X large, you could see that my memory, it offers less memory, but that's not really that important to me. But it also gives me more CPU. And it does it at a lower cost. So I now save 23% on each data node just by allocating a different EC2 type. The other cost savings I can get from EMR by doing this type of analysis is that AWS gives you the ability to resize your cluster at any time during the run. So if you run it for several hours, but you don't need as many hosts on the second half, you can now reduce that. And if I look at that, I see that exact scenario. My memory is low and then it tails off. But same thing with CPU. After the first 2 hours, I really tail off to less than 50%. So we're going to make the decision here to, during this 4-hour run, is to reduce the number of hosts that run. And if I look at the cost, the original cost, it's the number of hosts, which is 40 times the number of times the price per instance, and the number of hours that I ran. And it came to $56. But if I now run 35 hosts on the second hour and 20 hosts on the third and fourth hour, I can reduce my cost by 28%. Now let's try to use both methods for a full cost resizing. So the original cost was $56, but if I use the different EC2 type and I resize, I can decrease the cost to just $31 to run that same cluster. And that's a saving of $24.95, which doesn't sound like a lot, but you have to do the full analysis. We run that transient EMR cluster 5 times a day. And then we run it every business day. And we also run it every week of the year. So that's a savings of $32,000 for us just by resizing. So we haven't affected performance a bit, and all we've done is made it more efficient provisioning, and we've saved $32,000. At FINRA, we run over 7,000 of these transient EMRs every single day. So the cost-saving potential by doing this type of analysis is incredible. Okay, to wrap up here, because we process the file, we're able to do back tagging. So we count on developers to tag their devices correctly, and sometimes they forget to tag them or they tag them incorrectly. We can now go back, since we processed the file and back tag after they've made the adjustment, and that's really powerful because it provides more accurate data to the project managers. We're doing more drill down analysis as I just showed you with EMR. We're providing user-defined alerting so that they can decide when they're over-provisioning and get alerts on it. And finally, we're now looking to tap into Splunk's IT service intelligence, where I can now get really great visuals of indicators of performance, and it provides a great way to centralize this so that I can have one group be able to get the notifications and dole that information out. And finally, I'm providing a YouTube link over here. We've done this presentation at reInvent, and we've gone through it. We go through it much slower, so that if this was a little too quick, I apologize, and it's available on the YouTube. And if anybody would like to reach out to me, you can reach out to me at LinkedIn, and I'll be glad to talk to anybody about cost pricing. Love to talk about it. Oh, one more data point. So we did have we bought a third-party solution, and that third-party solution handled our cost management. And because of the work that we did on Splunk here, and we've shown that we're able to actually manage it much better than we did with a third-party solution. We quickly outgrew it. And now that we're not going to re-up that solution, it winds up that solution that only did cost management costs more than our entire Splunk implementation. So we've not only have we saved money in AWS, we've saved money for our cost management strategy. So it's been a big win. And with that, I'm going to turn it back over to Amilcar, and thank you very much.
Thank you so much. So with this, let's continue and wrap up the presentation. So as you've heard throughout the talk, one of the things that we've really looked into is how the ability to drive cost reductions, cost optimization being able to plan and more effectively resize, increase the level of utilization, drive the right size of instances that you need for your workloads. With AWS, you can certainly and more easily move quickly because now, and this is one of the points that we want to stress, when you make a capital expense, you're pretty much tied up to the infrastructure that you've acquired. So the ability to move back and forth is really constrained. But with AWS, you have the flexibility to adjust with much more effectiveness on the fly to whatever type of instance type, whatever scenario you need to match, to whatever capacity you need to address, and really never have to underserve your primary stakeholders. Similarly, because it can be done very easily and it can be done essentially with a click of a mouse, you can hit your deadlines. You don't have to go through an extensive procurement process. You don't have to go through a lengthy evaluation period to even get the solution tested. You can really go and try very cost effectively, experiment, and if it doesn't work, you can try again, and that allows you to move very, very effectively. This leaves you a lot more time to focus on what differentiates your business. So you move the undifferentiated heavy lifting to us, and you can continue to work and optimize your solutions in order to get the most value out of what you're best at, which is your business. Also, because of the nature of the AWS cloud, and as we mentioned, the ability to right size, to optimize cost, to optimize sizing, you can certainly drive faster turns. So you can even think about doing things ordinarily that would have taken several cycles or budget cycles. You can do them really, really quickly. This means that you will have fewer long and large projects. And this is something that we've learned not only from our own experience, but for example, one instance that we're going to describe in a minute is how long and large projects typically are more likely to exceed budget, they're more likely to run late, and they're more likely to fail in delivering full value. And I know that to a degree we're preaching to the choir here because we've all been invested in a project that hasn't met a deadline. So we know that the longer the project goes, the more likely it is to become more expensive, to not drive the value that it's supposed to do, and that we might never even deliver the full functionality. We know that each additional year in a project boosts the likelihood of missing the target by 15%. So that's pretty material. That's a very significant level of investment. McKinsey ran a study where they basically evaluated 5,400 IT projects with $66 billion in cost overruns. And I would make a bet that some of that money is allocated to some of us all over the place. So how much money can you save by moving to the AWS cloud? As we mentioned a minute ago, you can also experiment and drive much lower risk because the ability to test different things concurrently, do them consecutively at a very low cost allows you to really drive a level of experimentation that would have otherwise been prohibitive on an on-premises environment where just the setup of the infrastructure could have taken a lot of time and a lot of cost that would have really driven no value because you were not really doing the work until that infrastructure was set up. Today, with AWS, you can just experiment and trial as you see fit. So to put it all together, what are we looking at? So the value of AWS, as we mentioned earlier, is not just the value that you get in your first deployment. It's something that accelerates over time. When you invest $1 of AWS, you typically get $3.50 in benefits over the first 36 months. So that's a really nice, healthy return. However, the real benefits come when you think about the longer term. When you invest $1, you get almost $8.50 in benefits over 60 months. So those returns are certainly something worth of consideration because you're putting money into your organization that is not only going to pay back relatively quickly, but the benefits are going to accrue and the returns are going to be incremental over time. So what do you want to do next? So the first thing is when you're thinking about AWS and cost optimization in particular, you want to establish a cloud center of excellence. We want to stress the fact that really understanding cost optimization, understanding the virtues of utilization, right sizing, being able to track, tag, and model correctly requires a team of individuals or a small group of individuals that are really going to be dedicated to understanding how this all works and how it all is put together in the context of your business. So setting up a cloud center of excellence is really of critical importance. Leverage the AWS global footprint. If you have a global business, you can trial and work on your solutions across 11 regions, 30 availability zones, use all the services you need, and leverage all the innovation. So you can truly have a one-stop shop to deliver a vast number of solutions that otherwise would have required multiple pieces to tie in together, and you can do this on a global basis. So this will result in lower costs, increased agility, the ability to scale based on market needs, and innovate around your unique value. That is truly the message that we want everybody to leave with. I mean, the true benefit of using AWS is to allow you to differentiate and focus on what you do best, and let us help with the infrastructure and do the heavy lifting of something that is expensive and difficult to do when it's not necessarily your core competency. And lastly, you can leverage what you've already owned. We know you've made significant investments in technology that you want to maximize the value out of, and AWS supports that pretty effectively. Now, if you need a little bit of extra help, if you need to get to that last mile, AWS has tens of thousands of APN partners, a marketplace with over 2,300 software listings in over 30 categories. So that will help you really get to that next level if you do need that ability to cross the finish line. So for any additional information, please visit the Economics Center, aws.amazon.com/economics, brand new redesign of the Economics Center. There's a link to the TCO calculator, and we have a number of resources and references, including white papers, case studies, and a number of other things. So with that said, we are concluding this presentation. We thank all of you for spending an hour. Hopefully this information was valuable.
Thank you, Amilcar and Gary, for a great presentation, and our Q&A moderators for facilitating questions throughout the presentation. Now, if you can see, there are 3 poll questions to the left of your screen, and in this time, we have about 6 minutes. So our Q&A moderators are still answering questions in the Q&A pod, so feel free to submit any questions. And we have many questions asking about whether you can have a copy of the recording in a deck. Yes, we will. As I said, we will verify the quality of the recording, and also we're going to upload the slides to a public domain. So we will send you the link to both of these on-demand URLs in a follow-up email in the next several days.
Hello. So we have a question that talks about using or use cases for the calculator if there are some pre-built calculations like a standard business case or scenarios for startups that can be referred to. So there are two ways to think about this problem. So the first is the actual evaluation of the cost of ownership, and the other is the pricing of what you're actually going to be paying for the actual consumption of services, which are not necessarily the same thing. We currently don't have pre-built scenarios or work or use cases for startups, in particular for the TCO calculator. However, our simple monthly calculator that allows you to do some cost analysis of what you're actually going to pay in services does have the ability to templatize and get some workloads that are pre-built, and that you can very easily put some numbers in depending on how much you think you need. For example, for a web server, or for some simple database solutions that are relatively straightforward. The issue with those scenarios is that you have to certainly know to a large degree what you're going to be needing in terms of technology, so you don't misprice and underestimate or overestimate the solution. But the simple monthly calculator does give you the ability to use some templates and pre-built scenarios. The TCO calculator does not at this point.
Hey everyone, sorry we could not get to everyone's questions, but we have everyone's question in our report, and we will send you a email if with any pending answers from the team. So I'd like to extend a special thank you again to our presenter and moderators and our audience, especially for our time today. If you have any comments on our previous and upcoming webinars or suggestions for topics in which AWS may cover in future webinars, please feel free to email to aws-webcasts@amazon.com. Again, the email address is aws-webcasts@amazon.com. Your feedback helps improve our webinar programming. Thank you again and enjoy the rest of your day. Cheers.